Okay, we're moving on now to, I think this is 7E. Okay, an exam favorite coming up. So if you take a look at that graph there on the board, don't worry too much about the numbers on it. But what do you notice about it? And I'll tell you that what we've actually drawn is the graph of 3 sine x plus 4 cos x. And you might be surprised at its appearance. Well, that's because it sort of just looks like a sine graph. And when I say a sine graph, I mean, a sine or a cos graph, because really they're the same thing, just translated, aren't they? You might notice, though, that it's not going up to 1, is it? It seems to be going up to a number here, maybe about 5 or 6 or something. And similarly, it seems to be going down to about -5. So let's say about 5 -5. It's not starting at the origin here like a sine graph is, and it's also not starting falling either like a cos graph is. So you could also say, as well as being sort of stretched, it looks like there's been some translation left or right. So we'll come back to that in a moment because there's a very good reason for that. Okay, so let's start with the same thing again, 3 sine x plus 4 cos x. And we're going to show that, in fact, that can be rewritten. Another way to write that is this. R is some number and alpha is some number as well. So in other words, we're going to show that really it's just a sine graph that has been stretched, okay, and that has been translated. So how do we do this? Well, step one, kind of counterintuitively, they will 95% of the time, they will give you this in the question. We're going to start with this one here. So we're going to expand this because that's an addition rule, isn't it? And we know this is sine x cos alpha and so on and so on. So if we expand it, we get something like this. You can expand the r out if you want to, or you can keep it at the front. It doesn't really matter, okay, for the first step. Let's sort of write this out again. So let's do r sine x. R sine x, in fact, I'm gonna do that. I'm gonna do that again, and you're gonna see why in just a second. I'm gonna rewrite this as r cos alpha times sine x. And then this part here, again, I'm going to change the order of these parts here. You'll see why in just a second. So yeah, let's expand the r. R sine alpha cos x. So that's what happens when you expand out this form. And this form is supposed to be the same form that we're supposed to write this in. Well, if I write this underneath, 3 sine x plus 4 cos x, you can sort of compare coefficients here. It works because it's like an identity. That's the reason why you can compare coefficients. So what goes along with sine x in terms of how we need to write it? Well, r cos alpha. And what goes along with sine x in terms of what we're dealing with? It's 3. So these then must be equal. If we are to write it in this form, these parts here need to be equal. We can do the same over here. What goes with the cos x? R sine alpha goes with the cos x, and what number goes with it? It's 4. So you can make two sort of mini equations by doing this. So r cos alpha equals 3 and r sine alpha equals 4. You don't have to change the order like I've done here. You might be able to see it after a bit of practice. What goes with the sine x? 3. What goes with the sine x? R cos alpha. You might be able to do it like that. That's also fine. But when we have these here, we can do some work with these two equations, and it gives us everything we need to finish this off. Okay? If you do Pythagoras on these numbers, treat these like short sides. 3 squared plus 4 squared, you get 25. And if you square root that, you get 5. And that's all the working out you need to show for this section. That r, that 5, that's how much we've stretched the graph by. And you might think, well, why does it work? Well, it tells you down here why it works. Okay? if you square these and add them together, you get r squared cos squared alpha plus r squared sine squared alpha is 3 squared plus 4 squared. Okay, you take the r squareds out, sine squared plus cos squared. Again, you don't get asked to do this, but I'm just showing you in case you're interested. Sine squared plus cos squared is 1, so r squared is 25, and r is 5. Okay, we take just the positive value from this one. So you can just write the last line. Okay, so the stretch is a scale factor of 5. What else can we do? So we can also take advantage of sine alpha, cos alpha. If you divide them by each other, the r's will cancel and they will leave you with tan alpha. Okay, so tan alpha is going to be equal to 4 over 3. Why? Because r sine alpha is 4 and r cos alpha is 3. If you divide them, you'll get sine alpha over cos alpha equals 4 over 3. So look, you can find your angle that way. That's another cool sort of thing that happens when you do this. So you found the stretch scale factor and you found the translation, 53.1. You put it all back together, and what you have done is you have shown that this can be rewritten as this. A stretch, scale factor 5 stretch in the y direction, and translation of 53.1 to the left. Okay, you'll see that in fact is exactly what's happened. Okay, so we can take something that is two separate trig functions that are being added or subtracted together, and we can rewrite it into one if we're dealing with sine and cos. So one more quick example, sine x plus cos x. So I'm going to rewrite that as a 1 sine x plus 1 cos x. Okay. If I expand this one out, I get r of sine x sine alpha. Whoops, that's wrong. Sine x cos alpha plus cos x sine alpha. Now, the part that is, this is a little bit hard to read, that's an x. Let's make that easier. The part that goes along with the sine x here is r cos alpha. So the part that goes along with the sine x is r cos alpha. What goes with the sine x here? It's 1. So r cos alpha equals 1. Same again. So this r, don't forget, has to be expanded still. So what goes with cos x? R sine alpha. R sine alpha equals 1. You might remember we said Pythagoras is the shortcut. So 1 squared plus 1 squared square root equals root 2. That is the stretch. I don't have to show the full detail of why that works. This is enough. And if we do r sine alpha, which is 1, over r cos alpha, which is also 1, that tells us that tan alpha equals 1. And I use my calculator, okay, and that will tell me the alpha, giving in terms of pi. So what's that going to be? It's going to be 45, so it's going to be pi over 4. Put these values back in, and you get root 2 sine x plus pi over 4. Okay, and that's what we're looking to do. So you'll get quicker and quicker and quicker at this until you can sort of do it at the same speed. Pause the video and have a go at that your turn there. Okay, so just by inspection, 1 squared plus root 3 squared, we're going to be looking here at 2. 2 is going to be your r. Okay, and the r sine alpha, r cos alpha, you need to do that to get the correct value for tan alpha. So that takes a little bit more time. But we should have a final answer of 2 sine x minus pi over 3 like that. So please make sure you follow those steps there. And it's pretty much rinse and repeat for that type of question. Very, very common exam question. Nice place to pick up a couple of marks. Okay. let's go a little bit further with this now then. So put 2 cos theta plus 5 sine theta in this form, and then hence solve. Okay, well, let's just put this into this form first, because it tells us we need to do it anyway. So 2 squared plus 5 squared, and the square root of that, so root 29 is going to be r. Okay, I wish I could do the other part as quickly as that, but unfortunately I cannot. So r cos theta cos alpha plus, so I'm expanding this part and multiplying out the r as well at the same time, r sine theta sine alpha. So what goes with this cos theta of the original? 2. So that's 2. R cos alpha equals 2. Okay. And the other part here. So 5, a positive 5. So R sine alpha equals 5. The pluses are the same, so I don't have to worry about the pluses. So R sine alpha equals 5. So tan of alpha equals 5 over 2. And you can see that I can work out alpha from there. So let's focus now on the rest of the question then. So hence solve the equation this equals 3. Well, look, that is exactly the same as that part there. So I need to take my answer and I need to set it equal to 3. So let's just reveal. So where is my answer? This is my value here. That's what's the same as 2 cos theta plus 5 sin theta. And I need to set it equal to 3. That's the next step. It might look a bit complicated, but divide by root 29. And then when you're at that point there, that's solving trig equations like in year 12. Okay, so you can solve that one there and you can answer this. Let's look at another variation as well. So without using calculus, so no differentiation, please. Find the maximum of 12 cos theta plus 5 sine theta and the smallest positive value of theta at which it arises. Okay, so it doesn't actually tell you which form to use here. So you can use either of these forms. But if you use the cos one, let's just use the cos one because that's what they have, you would be able to turn this into this. 12 squared plus 5 squared, square root 13, and so on and so on. You would be able to get this. Now, what is this here? Well, this is a cos graph, isn't it? Cos starts up here normally and goes like that. And because there's a 13 there, it's not going to start at 1 anymore. It's not going to go between 1 and minus 1. It's going to go between 13 and minus 13. So when they say to you, what's the maximum value? Well, the maximum value is going to be 13. So you don't need to do any differentiation or things like this. You just need to understand what sine graphs and cos graphs, what they really look like. So that's the stretch. What's this bit here? Well, this is a translation to the right by 22.6 degrees. So it's not a massive amount that is moved over that way, but it means that the graph actually looks a little bit more maybe like this. Okay, so when does it reach its maximum? Well, it used to reach its maximum at 0 because that's where cos graphs start off, but it's been moved to the right by 22.6 degrees. So its new maximum occurs when theta equals 22.6, and that maximum, the value of the maximum, is 13. So if you understand your trig graphs well from year 12 and your transformations well, it comes in useful for these kind of questions here. That is worth at least 2 marks normally, what we've just done. Just talking about the 13 and the 22.6. The other part is worth a few marks before as well. But they're very, very easy marks to get if you're good at graph transformations and you understand like what sine and cos goes in between. So we're going to practice that idea very quickly now. So what's the maximum and the minimum each time of what's given? And my advice is going to be to think about sine graphs and to think about cos graphs. So sine normally goes between what? 1 and -1. So what's 20 sine theta going to go between? Well, it's 20 and -20, isn't it? Now, it's not always on its own. Sometimes something's being done to it. So look, 10 sine theta. Well, 10 sine theta goes between 10 and -10. So this part here, you could think of this as being anywhere between -10 and 10. At the start, it says 5 minus. So 5 take away a number. How can you make the biggest number possible? 5 minus -10. In other words, 15 is the maximum value from that there. What about the minimum value? The lowest number or the most negative number that you could make? Well, 5 take away 10 would be -5, would achieve that. Okay, let's do another one. 3 cos of theta plus 20. Which parts here affect and do not affect the range of values? Remember, the range for a cos graph is normally 1 to -1. Well, the 3 is the only thing that affects it. So it will go between 3 and -3. The plus 20 does not impact the range. It impacts when the maximum and minimum happens. And finally over here, this is one to sort of confuse you a little bit. So how do we read this? Well, sine of, it doesn't really matter what goes in here. All of this is just going to be between 1 and -1. So think about how you can arrange these numbers so that they give you the maximum value. So the answer is you want to make the denominator as small as possible. So 3 lots of -1, so it becomes 2/7. Whereas the minimum, you divide it by the maximum number possible. This is about as hard as it gets normally, this difficulty here. So you just need to slowly reason through your understanding of the range of a sine and a cos graph. Okay. And what have we got here? So we've just got a couple of general cases, I suppose. If you wanted to say exactly what's going on, what I'm saying here is when we see sine, we think of -1 to 1. Cos, -1 to 1. Cos, -1 to 1, don't we? Okay. And depending on which values you pick along here, these tell you your minimum and your maximum values. It never quite gets presented in this way here, but this is essentially what's going on. And the exam questions look very similar to this one here. So part A is take this thing here and rewrite it. And then for part B, we're supposed to notice that is the same as that part there. Okay, so let's just reveal. So this ends up becoming 10 cos of theta minus 0.927. So you're meant to sort of substitute that whole part there with this. So it becomes 4/12 plus 10 cos of theta minus 0.927. And now that looks something like what we were dealing with on the previous slide. What's the maximum value? Well, the maximum is when you make the denominator as small as possible. So I could make all of that -10. So that could be -10. So 4/12 minus 10 is 2. When does it occur? Well, that one's a little bit more difficult on this one, okay? That one's a little bit more difficult. But you can, I mean, how would I suppose I'd go through that? I suppose I'd sort of sketch the graph to think quite carefully about it. The problem, what's the problem on this one? The problem is you have to use symmetries. So theta minus theirs equals pi. Okay, so that one's a little bit more difficult, but hopefully you can see what I'm sort of getting at is part A is about rewriting, and then part B is normally about substituting in and sort of using your results somehow. And a maximum or a minimum question is quite a common type of question to be asked. Okay, so that takes you up to the end of 7E. You could have a quick go at those ones there on the board to start with, following the steps. Okay, and you'll be coming back to this near the end of the chapter for modeling questions based on this.